Okay, so here is unit 3. Notice this one is a lot longer. That should be a really good hint to you that you really want to make sure you understand these concepts. It's a big thing to cover. First question, if something is changed, so if a transformation changes the size, that's what not congruent means. That's going to be a dilation. That should be a pretty much automatic one. Which transformation would not always produce an image that would be congruent? Again, we're looking for dilation. Those two should be pretty easy questions. In the diagram below, they give us an image and a pre-image. Pay attention to which one is the image always, so that's where it ended up. So I know that it's a reduction right now because I know ADE is where it ended up. They tell us that there was a scale factor change. So really they're just asking us what's preserved. So I can get rid of 3 and 4 because the angle measure doesn't change. It stays the same. And now I just need to figure out which of these two are the corresponding ones. So if I look at BAC up here, BAC, so I go like 2, 1, 3. AED does not go in that same order. Whereas ABC, first, second, third, ADE, first, second, third, that's the one because it's in corresponding order. Question 4, we have the vertices given. Under which transformation will it not be congruent? Again, I'm looking for dilation anytime they talk about them not being congruent. We have a 3-inch line segment dilated by a scale factor of 6, centered at its midpoint. Because it's centered on the line, it's going to be just a usual situation where you do 3 times 6 and get 18. Same question here with number 6. It's asking which one is going to change size because it's saying the perimeter is different. That's going to be the dilation. This time, instead of having the word, you have to find it. Whenever multiplication occurs, something gets bigger or smaller. Excuse me. So that's why it's choice 3. In 7, we have the information given. Which one cannot be proven similar? Remember, angle is usually a yes for similar. So I'm going to look for that one first, and it's right here in choice 2. So I'm getting rid of that. This is side angle, side angle, side. We know that that works. So that one would be a yes, not a not proven similar, which then leaves us with the 2 up top. 12 divided by 3 is 4. 9 divided by 3 is 3. That one means it is proportional. 16 divided by 8 is 2. 32 divided by 8 is not 8. So that's why it's choice 3, because it is not proportional. There was not a scale factor that created the image. In 8, they tell us a dilation occurred. So basically all we know right now is that those 2 lines are parallel. We have no idea what the scale factor was. They just want to know what's always true, and that's going to be that parallel line answer. It wants you to understand that dilations preserve parallelism. They also will do the same question sometimes and talk about the corresponding angles that I'm currently marking, those types of things. Under which transformation the image not be congruent? Again, I'm just looking for that dilation. What would have happened here? So they got the size change. So right away, 1 and 2 are out. And then was it a translation and a dilation or a dilation and a rotation? A translation, I'm hoping you realize AB prime would be parallel to AB if it were slid up after it had changed sides. So this is a rotation because the shape turned. In question 11, they give us that we have perpendicular lines, which were already labeled for us, the 2 triangles, and they want to know what would actually transform to show that they are similar. Remember that symbol right there means similar. So a rotation followed by a translation, no, because a dilation definitely occurred. Rotation followed by a translation, again, no, because a dilation occurred. So now we're choosing between 3 and 4 because they both have dilation. Scale factor of 2 in both. So now was it a rotation of 90 or was it a rotation of 180? 180 would look like it turned completely around. So I'm hoping that visually you understand why that's 90 and not 180. If not, you can turn your paper to check. 12, again, we're identifying transformations. If you had your compass, you could just double check that a dilation did not occur. It didn't. So we're going to get rid of that. It didn't get bigger or smaller. And it also, where else? No, that's it. Okay. So now, was it a translation followed by a rotation or was there a reflection involved? The way to check that part is, remember, when it flips, the orientation changes. So I see I'm going A, E, D, C. If I start at A and go the same direction, I'm not saying B next. So that means a reflection definitely occurred. 2 reflections make a rotation. They undo that whole system. So that's why it's a choice 3, a reflection, and then a slide over. In question 13, they give us a diagram. Always pay attention here. AC is going to be my X. That's that entire distance. So automatically, I'm going to put the corresponding measure to the left of that. I will then set up my proportion because these triangles are similar. I know they're similar triangles because similar triangles are created from parallel lines because parallel lines make proportional parts. From here, I'm going to set up 9 is to 14 as 9.2 is to X. If BC was your X, you should have 5 over X. And that would be a way to solve it. You would just need to make sure you pay really close attention in the end. So 9.2 times 14 is 128.8. I'm cross multiplying right now, equals 9X. I would then divide by 9 on both sides and end up at about 14.3. Check AC is what I marked X as, but always double check that. And then 14.3 is the answer. Next question, what happened to map one triangle onto the other? It was not a dilation. It was definitely not a translation. And then you're deciding between line reflection and rotation. And again, if you turn your paper physically, you would see that that would get it to where it needs to be. Again, for the dilation, I would just check that each side, like 2, 3, that they're all the same length. The next question, what relationship must always be true? So they gave us a whole bunch of information. And then I'm looking down here right away to just kind of see, they're talking about angles in my multiple choice question. So I'm immediately getting rid of 1 and 2 because angles are the same in a dilation. They preserve angle measure. Now I just need to focus on the order of the letters here. So I'm just going to rewrite them so that I can see them on the screen. So A and D should go together, E and B, F and C. So A to C, that should read D to F, but it doesn't. It reads F to D. It goes in the wrong order. B to E, and then C to F. That's the one, choice 4. You have to go in the corresponding order and also the same direction. So like if you start in the left triangle, you need to start in the left triangle the second time as well. Triangle ABC and DEF are drawn below. They gave us some information. So AB is 9, BC is 15, DE is 6, EF is 10, and angle B is congruent to angle E. Which statement is true? So automatically you should be thinking about similar triangles. So my gut is telling me right there. Now I'm just going to check. So 15 to 10, CB is to EF. Does that match here? CB corresponds with EF. Okay, I'm good because it's the last 2 letters. And then AB corresponds with DE, so equals 9 over 6. Again, I would just double check that up here. It works. 9 times 10 is 90. 15 times 6 is also 90. So this means that it's a proportional relationship and the triangles are similar. The next question, we have a scale factor of 3, and they want to know what's true. Again, I can get rid of the angles being multiplied by anything because angles stay the same. And then when you're choosing between choice 1 and choice 2, I encourage you to just draw a really quick picture to help you figure out what's happening here. If it's a scale factor of 3, what is getting multiplied by 3 to create that? It's the pre-image that's getting multiplied by 3. So that's why it's choice 2, not choice 1. The pre-image, the BC, is getting multiplied by 3 to create B prime, C prime. In the next triangle, we have them given to us similar. This is one where I would always encourage you to draw them separately. So like here's triangle A, D, E, this top one. And then I would draw triangle A, B, C separate. It just helps. Notice in the multiple choice here, it's all the same. AD to AB, AE to AC. They're all, there's no difference there. So I'm going to just quickly highlight what it is that I'm looking at. So AB corresponds with AD, and then AE and AC. Okay, so those are corresponding sides. So now I really just need to figure out which one is proportional. So 3 times 2 is 6, 4 times 2 is 8. Wrong. 5 times something is 8. I don't want to think that hard right now. Maybe it's that one. I'll go back to it. 3 times 3 is 9 here. 5 times 3 is 15, so it's not that one. 2 times 3 is 6. 5 times 3 is 15. It's choice 4. I didn't have to bother with choice 2, but I would have just used my calculator and said, is 8 over 5 equal to 10 over 7, and saw if that worked. In the next question, it's a scale factor question, so we're just trying to pay attention to image over pre-image. Remember, scale factor is always image over pre-image. So before I even really get into this, I'm focused here, the image of AB. So CD is the image. So CD over AB. Do I see that anywhere? Nope, because they're using E, which is absolutely fine. But notice A should never be on the bottom. And if you look through all of these choices, or excuse me, A should never be on the top. A's on the top there, A's on the top there, A's on the top there. This is the only one that A is not on the top of, because EC is my image. EA was my pre-image. So E to C over E to A is the correct choice. And it's that quick. We have a similarity ratio. What I would do for this one is I would just set up a proportion. So I would write that as 1 over 2 equals x plus 3 over 3x minus 1. Cross multiply, I get 2x plus 6 when I multiply that way, equals 3x minus 1. I then subtract 2x, I add 1, I get x equals 7. I don't circle that yet. The length of GR is here. So 3 times 7 is 21, minus 1 is 24 is the correct choice. Remember, do not circle when you get x equals 7 until you've reread the question. And the next question, again, we're given similar triangles. AC is 12, DC is 7, DE is 5, and the perimeter of this triangle is 30. They want the perimeter of this triangle. Perimeters are also in proportion to sides, so we can set up the perimeter in the proportion. So I now need to figure out what 12 corresponds to. So 12 is AC, which are the last 2 letters. Again, if I go back up here, AC are the last 2 letters, or excuse me, the first and the last letter. DC is the first and the last letter. So now I know that it's 12 and 7 that fit my proportion there. So I get 210 equals 12x. That's an X, I swear. And then I divide 12 and I get 35 over 2. Remember, if that happens, just you can hit menu, number, convert to decimal, or you can just retype it in 35 divided by 2, put a decimal point after the 2, and your calculator will convert it for you as a reminder. Next question, we have a distance. The diagram is there because of these perpendicular lines, both to the same. We know that those are parallel and therefore creating similar triangles. They want the length of B to C. Again, redraw them as separate triangles. When you do, it's going to make you realize that this is not part of your proportion. So 230 plus 85 is my length of my second triangle, whereas 230 is my hypotenuse length of the first triangle. 120 is here, x is here. So my ratio should be 230 is to 315 as 120 is to x. Again, there's always 4 correct proportions. As long as when you cross multiply, you're multiplying the same numbers as me, you set up a correct proportion. Divide by 230 on both sides, and I end up with x equals a decimal. So I'm just converting that decimal right now, like I told you how to do a moment ago. X equals 287.6087. Nearest yard. That makes me feel better about my answer because I know that I didn't, oops, I screwed that up. Oh, no, I didn't. I'm good. I thought I erased a number on accident. So 288 yards would be how I round that. A flagpole casts a shadow 16.6 meters long. Flagpole shadow 16.6. So right now I'm like, ooh, is this a SOHCAHTOA question? Maybe. Tim stands at a distance 12.45 meters from the base of the flagpole. So here's Tim. This is 12.45. That's Tim. That's a person, I swear. his shadow meets the end of the flagpole shadow. So his shadow is here at the same spot, creating this triangle. If Tim is 1.65 meters tall, determine the height of the flagpole. So basically this is simply shadow to shadow. You just have to do a little bit of work to find Tim's shadow. So 16.6 minus 12.45 gives Tim a shadow of 4.15. So now it's simply flagpole height to Tim's height equals flagpole shadow to Tim's shadow. And then we cross multiply and solve. So 16.6 times 1.65. I'm moving over here because I'm running out of space. Sorry. 27.3. Oh, 27.39 equals 4.5x. Divide by 4.5 on both sides. And we end up with 6.08 and some stuff. Nearest tenth would be 6.1, which that, that makes sense. It's good so far. Okay. Using a compass and straight edge, construct and label the triangle after a dilation with a scale factor of 2. I do not have a compass and straight edge on the computer, so I'm going to sketch what you should do. It's centered at B, so you're going to grab your straight edge. And the first thing is to create a linear relationship between the center and any other point. In this case, that's just A and C. Then you grab your compass point at B, you set your pencil at A, and that counts as 1. You then move the compass point to A and copy it again. That is A prime because that's a dilation of 2. You do the same thing for C. That's now C prime. You connect, label B as B prime because that stayed right where it was, and that would be a dilation of 2. It says describe the relationship between the lengths of AC and A prime C prime. And you could say 2AC equals A prime C prime, or you could say A prime C prime is double the length of AC, anything like that. They want you to show that you understand that it got twice as large. Next question. We have an image after a translation. Describe the transformation that was performed. Saying a dilation isn't enough. You're correct, but you'd have to go further. So a dilation, you need a center and a scale factor. So remember, scale factor is image over pre-image. That we can get pretty quickly because we have a nice flat side here. So B prime C prime is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm hoping this is 5. Oh, did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's definitely 15. 1, 2, 3, 4, 5, 6. Okay. So, dilation with a, that says with a scale factor of 15 over 6, which you can reduce if you want to. I think it would be 3 over 2. It would. Centered at, now this you really do need a ruler for, so I might not do the best job right now, but I'm going to get it as close as I can here. So you have to connect your image pre-image pairs for this. So I would guess it's roughly at 0, -1 right now. With a ruler, you wouldn't have to guess. It would hit exactly on that point. But you need to not only give a scale factor, but also a center of dilation. Explain why they're similar. Dilations preserve angle measure. So A criteria makes them similar, would work. I probably could have written that nicer, but makes them similar. Hopefully you get my point of that, but you need to not only say that the dilations keep the angle measure the same, but you also have to connect that to why that makes them similar. And because angle is one of the reasons of why things can be similar. It's a criteria. All right, moving on to the next part of this. Now we're talking about congruent corresponding angles and proportional corresponding sides. So we have a diagram here with mid-segments. Mid-segments create a 1-to-2 relationship or a 1-to-1 relationship as part to part. Part to whole is 1-to-2. The perimeter of quadrilateral ADEF. Now at first glance, this looks like, oh my goodness, because it's all letters, right? What you need to just realize is that all of these are equal, okay? So every single one of those is equal. So really I could write it's 4 times AD if I wanted to. That's not an option, unfortunately. So I have to think a little bit harder. What you can do if you want to is label them all like 2, 2, 2, 2. The reason I'm saying to do that is because then AB is 4, BC is 4, AC is 4. So the perimeter of this that I made up, the numbers I just completely made up, 2, 4, 6, 8 is 8. 4 plus 4 plus 4 is not 8. Okay, half of AB is 2. Half of AC is 2. 2 plus 2 is not 8. 2 times AB. AB is 4. Plus 2 times AC is 4. Again, not 8. AB plus AC, that's it. That would be 4 plus 4, which is 8. Again, I made those numbers up, but it's just showing you that, like, this is 2, and then they're, like, those same 2 are here, right? We just kind of folded that one in. And then for AC, this part of AC got put there. So that's how you have this shape in the middle that has, I don't know why the highlighter's not working, whatever. Okay. So that is my suggestion as far as strategy goes. The next one, we have a triangle CHR, and then angle H is congruent to RDO. So the second I read that, I would redraw them separately. That's not the best drawing in the world. RDO. So that they look corresponding. So that when I set up 4 and 6, and then OH is 4. Where's OH? OH is here. Do I know what OR is? OR is 6. So RH is 10. They want the length of CD, which is this little chunk right there. CHRO is there, that is there. And then they gave us all of these options. Okay, sorry, I'm just making sure I got my head in the game here. And that's not a right angle. Okay, we know RD is 4. There we go. So I need to find the length of CR right now. So I'm going to set up X is to 10 as 6 is to 4. I get 60 equals 4x. When I divide 60 by 4, I get 15. So 15 is this entire length from here to here. 4 is already taken, so I subtract that and end up with 11 for the length of CD. That's a tricky question because it's super visual. The next triangle, or the next question, we're giving similar triangles with AB and AC labeled. What statement will justify similarity by SAS? So we need this angle and then the corresponding angle. So angle A is congruent to angle D, so these ones are out. And then I need the same scale factor or the same proportion. So 6 divided by 8, when you type that into your calculator, I mean, you can do it in your head, you get 3/4. That's not there. So now I need to type in 9/12 and 8/10 and see which one gives me 3/4. It's going to be the 9/12 because that's also 3/4. And that's how you would get yourself through that one. You're just looking for a proportional relationship and then the sides making that SAS. We have a diagram way below. Okay. We're given all that stuff. They didn't say the lines are parallel. Okay, that's what I needed to focus on. They give us everything else though, and then they want the length of CB. So they are parallel, but they're making you work for it. Your linear pair here, you need to solve for this being 65. Now that you know you have alternate interior angles, you know that 6 and 15 correspond, and then 4 and X correspond. So they made you work for it a little bit. So that would be your portion. 6x equals 60, x equals 10. Is BC what we were solving for? Yes, it is. The next one is a very similar one. They're just, instead of numbers, they're asking what would be true. So they're telling you AEC is similar to BED. So automatically, I would encourage you to like pencil, maybe black pen, BE, and DE, and then maybe if you have another pen or you brought a highlighter, DB and AC, because now I have all my corresponding sides labeled and I just need to find the one that works. So CE, black is to black, so far left side's good, but then they went EB. EB isn't in the same triangle as CE, so that one's out. Number 3, choice 3, EC to AE, so EC to AE, black to blue. BE, that's blue to black, so nope, not 3. AE is to BE. So AE is blue, BE is blue. And then they go green to green. So far, that one's looking like it's it. ED is to EC, so black is to black, as AC is to BD. They went in the wrong order. They went from the little triangle to the big triangle, then the big to the little. So it's definitely choice 2. In the diagram of the triangle, we have points D and E, and the lines are parallel. So again, I'm automatically jumping to similarity. AD is 24, DB is 12, DE is 4. The second I see that I'm using DE, I'm trying to remember that I want to label 36, because if I'm solving for AC, which I am, it's the 2 triangles. It's not the proportional parts that the parallel lines make. So 12 is to 4 as 36 is to X, not 24. Be super duper careful of this picture when that happens. I can't tell you how many times people know better, but they still don't do it. Divide by 12 and you get 12. AC was my X, and I circled that. Again, we have triangles. This is almost like the one we just did a little while ago. Angle C is congruent to angle OTU. And then they share angle U, so that's where the similarity relationship comes from. TU is 4, OU is 5, OC is 7. What's the length of ST? Yeah, so this is almost the identical question we did. I'm going to again redraw the other triangle, OTU, so that it looks like SCU. T, that should be a T, not a C, because it's a smaller triangle. There's T. And then I have O and U. Okay, there we go. So this is 5, and this is OT is 4. TU, OTU is 4. Whoops. I don't know what OT is. Good. There we go. Okay, so I'm going to have 5 is to 4. As now it's up to you. You can do X plus 4 is to 12. Whatever you choose to do. I'm going to do it that way because then that means that when I solve for X, it is in fact what I'm looking for. So again, I'm doing this side to this whole side right now. 5 times 12 is 60, equals 4x plus 16. Subtract 16 from both sides, we get 44. Divide by 4, we get 11. And again, I circled it because ST is what I labeled X as, and that's why I jumped to circle it so quickly. The next one, they want you to explain why AB is parallel to CD. So I would first show this proportion. So 3.75 is to 5 is 4.5 is to 6. Again, this is the parallel line creating those proportional parts. So we're good to go like that. And then I would cross multiply and show that I get 22.5 on both sides. Then I would say parallel lines cut segments proportionally. My work supports this statement, so that's part of my explanation. Parallel lines cut segments proportionally. That's why they're parallel. It made a proportion. Triangle RST and XYZ are drawn below. If RS is 6, ST is 14, XY is 9, YZ is 21, and angle S is congruent to angle Y. Is it similar? Justify your answer. So I'm going to go ahead and say yes, preemptively, SAS, because that's where my brain is going. The angles are labeled. Now we just need to show that the sides correspond. Oops, I just hit a button. Okay, so I'm going to do 14 over 21 equals 6 over 9. And again, I'm going to cross multiply and make sure this is true. So 6 times 21 is 126. 14 times 9 is also 126. And now my work and letters right there justify my answer. Okay, in the next one, we have parallel lines intersecting at A, and we're going to do a similarity proof. Remember, whenever you see a similarity proof, this is more than likely where that's going to come from. GI is parallel to NT. GI is parallel to NT. Okay, statements, reasons. First thing I'm going to say is my given. Again, make sure you write all of your given. I might be missing that whole intersect thing, but put that in there. I'm just not, because I don't want to scroll up again, and I'm trying to go somewhat quickly. Anytime you're given parallel lines, you want to find those alternate interior angles. There are two pairs. I'm picking angle I is congruent to angle N. My reason is I can't write this small, but alternate interior angles are congruent when lines are parallel. I'm saying it out loud because that's really messy. Okay. 3, you more than likely want to do your vertical angles, or you could have just in the same one given the other pair of alternate interior angles, which I'm going to do right now because I don't want to write that reason again. So now I can say, and you have to write it out, but again, I'm just really messy right now. Triangle GIA is similar to triangle TNA that needs to go there, and then angle is your reason. That's a really quick proof. Next proof is again similar. This time they're giving you a parallelogram. I'm going to just quickly highlight the two triangles I'm focused on. Oh, okay. It didn't want to work when I went the other way, but it wants to work now. Interesting. Let me try that again. I'm going to highlight triangle DEF and also triangle BGF. So that's where I need to get angles in. And I can see it right now with my parallelogram. I'm going to talk about lines being parallel so that I can get those alternate interior angles. And then I'm going to use these vertical angles, and boom, I'm done. So I'm just going to walk you through what I would say, just because the writing is so rough right now. So I would put all of this here, write it all out with the word, given for my reason. My second statement would be side DA is parallel to side CB. My reason is opposite sides of a parallelogram are parallel. Then I would say that angle, and I would not call that D and B because I can't, so I'm going to put a 1 and a 2 in there. Angle 1 is congruent to angle 2. This is that same reason from above. Alternate interior angles are congruent when lines are parallel. And then I'm going to put angle 3 and 4 in here to say angle 3 is congruent to angle 4. Vertical angles are, I can't write, this is so bad. Vertical angles are congruent. And then just like the one before, you write that entire thing right there. The triangles are similar, and we used AA criteria once again, which you will use often with similar triangle proofs. Home stretch. Medians, altitudes, and perpendicular bisectors. So here we go. We have a perpendicular bisector, so that means automatically I can label my right angles, and I can label that. Which conclusion cannot be proven? That EA bisects angle ZET, that EZT is equilateral, that EA is a median. Okay, that one we can get rid of right away. It is a median because it's drawn to the midpoint. A perpendicular bisector is a special kind of median, so that one is automatically out. Angle Z is congruent to angle T. We can definitely get to because they're corresponding. So here's my reflexive property, right? So I now know that these triangles are congruent. So all their congruent parts or corresponding parts are also congruent. So this is the only thing I cannot say, especially because it may or may not have been an equilateral triangle to begin with. So there's no way of knowing without actual numbers. That's why it's choice 2. Next one, we are constructing a median from 2AB. Okay, so I need to find the middle of AB. So compass point, pencil point, more than halfway arc. Compass point, same more than halfway arc. That has found the midpoint. The median means that you now have to connect from the opposite angle to there. And of course, this should all be done with a compass and a straight edge. That purple line or whatever color that is, that's the median. You have to go that step further. And that's it. So this was a little bit of a long one, but I hope it was helpful. The end. Have a great day. I'll see you later.